Okay, so we're going to begin by starting this lecture series, or I guess course in mathematics, by first actually thinking what mathematics actually is. So this is something that never actually gets taught, we never actually discuss, we just always think that it's been there. So maybe let's start with that first question. What is mathematics? So I think perhaps to be able to describe this, we have to think maybe of an analogy. So let's think of the Grecian analogy, which is looking at ourselves as people, as matter. So do excuse the drawing. I did mathematics, not drawing. Um, what we can think of is the Greeks told us that we're made of these little things, atoms. But what does atom actually mean? So what they were trying to say, they were putting two words together with the Greeks, that toms and the atom. So of course, tom means split, and a means from or don't. So what they were basically telling us that atoms were the smallest fundamental building blocks of matter, of ourselves, which couldn't be split. However, we've now learned that actually that is wrong. And again, if we kind of look at an atom, we usually see that, well, we have these electrons whizzing round, and we also have them built up of protons and electrons, and we have all these different parts. We might think there's protons, there's electrons, and we have fundamental other building blocks inside and neutrons as well, sorry. But okay, what else do we know? Well, we did some more work later, and there's been a recent paper, and it's shown us that we can further split these into smaller fundamental elements. So we have bosons, we have quarks, we have antiquarks. They're glued together by gluons. We have all sorts of different states of matter. So what I'm basically trying to get at is our fundamental idea of what matter is can easily be split down into finer and finer building blocks. So maybe we go back to the original question, what actually mathematics is. So what can we describe? What is the fundamentals which mathematics is underpinning it? So at the moment, one might think that the fundamental underpinnings of mathematics is numbers. So if we think what numbers actually are. So if we take numbers and we kind of think, well, what are they as a concept? So maybe we think something quite simple, that three pieces of paper. What actually are they? Or four pieces of paper, or maybe three students. What actually are they? Well, maybe we can think of them more as sets. So we have maybe as we've got four sets of paper, that makes a group of four. We have three students, which is a group of three students. These are independent different variables. Okay, so what significance is this? Well, this becomes quite significant when we try and think of actually what these sets are and how they can be grouped together. So, for example, if I had four sets of pieces of paper and I wanted to group that with three sets of groups of paper, I'll get seven. Okay, so this becomes our basic addition. Likewise, if I had three students and I wanted to get rid of three students, I'd get zero sets. I would have no students left. Or potential, we could say something, well, maybe what happens if I had, I don't know, three pieces of paper and I wanted to get rid of four pieces of paper? This gets a bit more difficult. We have negative one pieces of paper, which means if we rearrange this a little bit, we can move this here and that there. We can say that 3 plus 1 equals 4. So in order to be able to get this set, I'd have to add one extra set into the collection. Okay, so that's quite simple, but that's basically how we can think of addition and subtraction. Okay, so the next thing is, if that's our first operator, what about something a bit more complicated? What about multiplication? So at school, you'll have been taught multiplication, you'll have learnt your times tables, and you'll have learnt them parrot fashion more than likely, and you'll have listened to the tapes of the CDs, which will have shown you how it actually works. But actually, what can we think of multiplication as? And really, if we use the same kind of concept that we were previously describing of sets, I think perhaps we can just look at multiplication as being a fancy type of addition. So perhaps we could say that 4 times 5 is actually equal, well, 4, and we want 4 of those, plus 4 plus 4 plus 4 plus 4 plus 4, and we get 20, which is the same as 4 times 5. Likewise, we might say, okay, what about 5 times 4? So that's, again, well, we've got 4, that's those 5 plus 5 plus 5 plus 5, and we see that equals 20. Okay, so what we previously been taught is that actually these things are the same. Well, they're not, but they are in some respects. Is their answer is the same, but the way in which we get to the answer is not the same. So, okay, so multiplication is quite easy, but maybe we think of division. So if we think of a number, perhaps 15, and we want to divide it by 3. Okay, so what we want to do is find out how many of these 3's will go into this 15. So this leads to a basic subtraction problem. So we could say, well, 15 take 3 equals 12. Okay, so it's not 12. So then we can minus another 3, and we say, well, okay, that equals 9. Minus another 3, and we get that to 6. And we can minus another 3 that equals 3. Minus another 3, and we can equals 0. So we can say 1, 2, 3, 4, 5, and 15 divided by 3 equals 5. Okay, so that's kind of quite simple. But let's now bring in another construct, and something a little bit more complicated, which we always kind of wonder, I guess, when you're using your calculators. What happens if we have 0 in this equation? So, for example, what happens if we have 1 divided by 0? Well, we would then think, well, this has got to be 1 minus 0. Well, that still equals 1, so we can minus 0 again. We can 1 minus 0, and we'd go ad infinitum. But is that correct? So we'd say that this perhaps is infinity, right? Likewise, we could think of this from maybe another point of view. So we start with a number, maybe 1 divided by 0.1, and we'd see that equals 10. Okay? What happens if we then say something a bit more complicated, a smaller number, divided by 0.01 equals 100. Okay, likewise, 1 divided by 0.001 equals 1,000. So, as we make this denominator smaller, we're actually seeing that the answer we're getting is bigger. So again, that might tend towards infinity. Okay, so what happens if we now have a negative number? So maybe we have 1 divided by minus 0. Okay, well, we can't actually get, perhaps we could say this might tend towards negative infinity. Or again, if we use our same argument, we could say 1 divided by minus 0.1 equals minus 10. And we can do the same, 1 divided by minus 0.001 equals minus 1,000. Okay, so perhaps this would then tend towards negative infinity. But this now brings in a second argument. Makes us think a little bit maybe, because what would be 2 divided by 0? Well, 2 divided by 0, well, of course, we can use the same argument we had before. 2 minus 0 equals 2. Minus 0 equals 2. Minus 0 equals 2. So, again, we would expect that this would tend towards infinity. Likewise, if we say that 2 divided by 0.1 would equal 20, and we can go further, 2 divided by 0.01 equals 200, etc. So, would this not also mean that 2 divided by 0 would tend towards towards infinity? So yes, it does. So would that mean, therefore, if both of these equal 0, what mathematics tells us that 2 divided by 0 equals infinity, and also 1 divided by 0 equals infinity, well, surely we could sub these two infinities into each other, and we could say 2 divided by 0 equals 1 divided by 0, because of the same denominator, that will tell us that 2 equals 1. That's not correct. So actually, if you put 2 divided by 0 into your calculator, you would see that it becomes an undefined number. And it's an undefined number because the way in which dividing by 0 actually is undefinable. Because maybe we can think if we plotted this onto a plot like this, and we said that this was a plot of 1 over x, we'd see something that looks a little bit like this. And what we find is as we get smaller and smaller, as we showed earlier, we get a bigger number. This is x, and this, oh, sorry, this is y, and this is x, we get a bigger number, and it begins to get smaller and smaller and smaller, but it never reaches 0. Therefore, it can never actually be infinity, it can only be undefined. So that was a first taster of something what we're going to see throughout this course. I think it's quite an interesting problem. We're going to be looking at some algebra in the next video, and I'll see you then.